understand that in applications, you get to round to decimal places. If it doesn't tell you, always round to 2 decimal places. The reason why is you're not going to tell somebody that you are traveling the square root of 15 miles per hour. That sounds weird. You would do something like you would tell them you were driving 67.8 miles per hour. That makes more sense, doesn't it? So, application problems allow you guys to write things as decimals. If it's not in context, you must do the simplification of the radicals. So let's say that again. So in context, write as a decimal. And let's say that if it doesn't tell you how many spaces to round to 2 places. If it tells you, that trumps this here. So 2 places is hundredth. Without context, you must simplify radicals. You guys get to experience my amazing drawing skills. You'll learn that I never took an art class in high school, and you will see why. I do not have that skill set, and I wish I did sometimes. Some of you guys have some very beautiful drawings that you doodle all over your papers. Okay, so we have a wire stretched from the top of an 8-foot pole. So I have this pole. So that's a pole there. That's 8 feet. And there's a wire being stretched from it to a bracket 5 feet from the base of the pole. So there's a bracket down here, so some sort of a bracket down here. That's 5 feet from the base. And this wire is being stretched from the top of the pole to that bracket. You need to actually draw pictures while you're doing this, guys. Don't just start making up the Pythagorean theorem that you're using. Please draw pictures. Do they have to be beautiful? No, if you just want to draw a triangle, I'm fine with that. If you're really good at drawing and you want to make me happy and draw really pretty pictures, I'm okay with that. If you aren't very good at drawing and you want to draw pictures to make me laugh, completely fine with that. Either or is fine. But you'll notice that this forms a right angle. An opposite of a right angle we know is called the hypotenuse. So Madison, what would you tell me to set up to find that length of the wire? Yep, and I called mine C, so I'm going to write C on mine, but if you call it X, it's completely fine. So I have 64 plus 25 equals C squared. So 89 equals C squared. We know the inverse of squaring something is taking the root. So you're not going to do a factor tree for this. You're not going to tell me that the wire is the square root of 89 feet long. That makes literally no sense. So instead, you're going to do, in your calculator, you're going to use the square root button and do the square root of 89. If you have no clue where your square root button is, please let me know. It's above your square button, so if you hit second and then your square button, a root should come up. So second and then your square button, and then you can round, because it doesn't say, to 2 decimal places. So what is the length of this wire here? Landon?
9.43 feet.
Did he round that all right? It's not 4.4? Good. Okay, so since this is a contextual situation, I'm going to write this as a sentence. The wire is 9.43 feet. And it's super important that you use the unit just as Landon did when he told me the answer. Because I have no clue what you're talking about otherwise. 9.43 feet is vastly different than 9.43 inches. So you have to be very careful there. Wasn't you, Mariah? Sorry. I know, I was like, maybe it's Mariah. She was probably like, yes, I get out of Mrs. Brady's classroom. That's not what happened, though. Sorry. All right. So, laptop screen sizes are determined by the length of the diagonal portion of the screen, rounded to the nearest whole number. So I have a laptop. And the size of the laptop is determined by its diagonal. My wonky laptop. So it says rounded to the nearest whole number. This is super important for us because this is what we're going to have to round to in this case. So the laptop screen is 10 inches in width and 8 inches in height. Opposite the right angle is a C value. So that's what we're trying to find, is that diagonal there. Lexi, what would you tell me to do to find that? What do you complain about, Alana?
How do we have to draw pictures when we can just...
You don't have to draw it as exactly like that. If you wanted to just draw like a rectangle with the diagonal in it, completely fine. Just trying to make it a little bit more exciting than just a rectangle with a line in it.
Coffee and donuts would dramatically help with that.
That is true, but also I don't have a ton of money in my life, so.
Oh yeah, you're a math teacher.
I'm a teacher in general, so.
Sorry, I didn't mean to be. Sorry.
You're fine. So you wouldn't tell me that the length of this laptop is the square root of 164 or whatever that simplifies to. You would actually take the square root of 164. And when you take the square root of 164, you get 12.81. The problem is it tells you to round to the nearest whole number, right? So what is the nearest whole number of 12.81? 13. And remember, if it's 5 or bigger, you round up. 0 to 4, you round down. So this one is 13. So the laptop screen is 13 what? What is my unit? Inches. Now, this means that if this is how things work, if they have a laptop screen that is 12.6 inches actually, and you buy it and it tells you it's 13 inches, they're telling you that it's actually the wrong size based on that. Just so you know. Like, they could use that as a way to make it seem like it's more than what it actually is. Questions there? Alana, why do I have to draw a picture like that? Because I'm trying to make it more
I
exciting.
didn't mean like pictures like that. I meant just in general why we had to draw pictures. Maybe you could just...
You have to draw the picture so you know where things are placed, because you don't know if it's going to be the hypotenuse or what you're trying to find. You know what I'm saying?
Yeah, I wasn't
So the
thinking
picture, I know, I'm just
just...
joking around. What's up?
Since it's not exactly, do you just say it like about?
You could say about 13 inches. It tells you to round to the nearest whole number, so you rounded it that way anyway. So either or is fine.
Okay.
That's probably more accurate, yeah. A helicopter rose vertically 12 meters. Not 12 meters. That's 200 meters. Thank you.
When I'm a millionaire, can you design my vehicles?
Obviously a helicopter. I mean, you can't see it?
No, not really.
I'm sorry. Sorry. I do see the keyboard mouse. It has little legs on it. All right. Vertically, is that up and down or left to right? You two. Silence. Island is going to happen soon. So, vertically, is that up and down or left to right?
Up and down.
Up and down. So it goes up 200 meters. That looks 206. And then it flies to the left. So if you're thinking directionally, west is to the left. 300 meters. All of a sudden, we want to know the distance to its starting point. It also tells you that you want to know the total distance this helicopter traveled because it's going to go back to its starting point because it notices mechanical issues. So it's going to go up and out and go back because it notices mechanical issues. So to do that, we need to find the hypotenuse again. So Brandon Veman, set up the Pythagorean theorem for me.
300 squared plus 200 squared equals c squared.
So this doesn't tell you how many places to round to, so we're going to do to the 2 decimal places if it doesn't tell us. So to 2 decimal places. Cameron, what did you get?
665.
So it's not 665. The 5 stays, but the second 5 rounds up to a... Yeah, because it's 555, right?
Yeah.
So that 5 rounds it up. Okay, but that's not what it asks you. It does ask you for that first part, so this distance is 360.56 meters, but it asks you what the total distance is. Bryce, how could I find the total distance? We don't need the distance formula here. It's just saying the total distance he traveled. So he goes up, how many meters?
200.
He goes to the left,
300.
300 meters, and then he goes back home, Bryce, to how many meters?
360.56.
So what do you do with those pieces? You just add them together. I really like your laptop. I'm admiring it right now. What did you just say? It's 860.56? And then there's a triangle on Dylan's. Simple. It's photo math quality.
I like your little note.
Did you like my sad face with the tears coming out of it? There. All right, questions on that one. The big thing here is you got to make sure you're actually answering the question that is asked of you. So, like, it's not just asking you for that hypotenuse's distance, it's asking you to find the total distance. So, a lot of them have that extra application to it. Okay, here we go. When Joe drives to school, he picks up his friend Dave. Dave lives directly south of Joe. South is down. Quality car, right? That's Joe's car that he drives. Okay. The school is directly east, which is to the right, of Dave's house. It tells you that Joe drives an average of 30 miles per hour. So we aren't going to use this right now, but we need that later. So I'm just going to highlight that for later. We know that Joe lives 9 miles from Dave, and Dave lives 12 miles from the school. I don't know why these kids live so far away from each other and are this far away from their school, because I don't even live 12 miles from your guys' school, and I don't live in this district. So I don't know where these kids are really going to school. Must be. It could be a private school. You're right. Maybe they're driving down to the city or something. They're flying. Okay. How much time would Joe save if he didn't have to pick up his friend Dave? So we need to figure out what his distance down this road would be if he didn't have to pick up his BFF Dave. Your friend that, leeches on you because you got your license before them. You all have that friend, or you are that friend. All right. So, what Pythagorean theorem would I set up here, Ayana, to figure out Joe's distance to the school? If you're lucky, that friend gives you gas money, though. That's only if you're lucky, though, right?
No, he's on the. What?
You use everybody else, Dylan?
I mean.
You're that friend? Okay. So, you have their distances. So we want to know how much time would be saved, not the distance that is saved if Joe would just drive to school or if when he has to pick up Dave. So without Dave, Joe has to travel 15 miles. He drives at a rate of 30 miles per hour, right? Is that what it says? You get to use some unit analysis. You guys do that in physical science when you're freshmen. You love it, I'm sure. But we have to cancel out miles. So in 30 miles per hour, does miles need to be in the numerator or the denominator to cancel out? Where? Denominator, because it's already in the numerator. So for every hour you drive, you can go 30 miles, is what you're saying. But your time is probably not going to be in hours. What is it probably going to be in? Minutes. So we need to get hours to cancel out. So we need to do, for 1 hour is how many minutes? So we do 15 times 60 over 30 for how many minutes? So go ahead and figure that out. How many minutes is that? 30 minutes, which I guess, like you guys said, if it's a private school, I guess it could take you 30 minutes to get to school depending on where you go, but that would really stink. Because I don't even take 30 minutes to get to school. Huh? You take 20? But that's still not 30 at least. It takes me about 20. So with Dave, how far does Joe have to travel? How far does Joe have to travel with Dave? How many one? 21. I heard 41, so I just want to make sure I heard the right thing. So 9 plus 12 is 21. So it's 21 miles, and we already said that miles needs to be on the bottom. So for every 1 hour, he goes 30 miles. And we want our answer to be in minutes, and there's 60 minutes in an hour. So how many minutes does it take him when he has to go pick up his friend Dave or Dylan? What?
14.
So how much longer does it take Dave to get to school when he has to pick up Dave? I don't know if I just said that wrong. I think I said Dave's name twice. Dave, that's what I thought I said. I meant Joe. So Joe has to drive 12 more minutes when he picks up Dave. Okay, we have one more question. What questions you guys have so far? Now, do your pictures have to be this detailed? No, Dylan is literally just drawing triangles on his paper. I'm pretty sure that's what Brandon's doing. I'm fine with that. Maybe you aren't. No, you have little houses. Dylan is literally just drawing a triangle. I'm completely fine with that. I'm just doing this to give you guys a little bit more excitement today in today's lesson because you get to witness me drawing some very ugly pictures. Okay, Jill and Joe are both lifeguards on a beach, and they spot a man drowning between their two lifeguard posts. The flag between their two posts is 30 feet from the drowning man. Okay, so there's a flag. That looks not like a flag. Between Jill and Jax. It's not Jack, it's Joe. I just decided to change his name to Joe's lifeguard post. That flag, stop talking, is 30 feet from the drowning man. It's the ocean. I just can't draw, like, this is like the beach here. This is the beach.
Oh, yeah.
These are their lifeguard posts. This is the flag on the beach. So, like, this is sand here. You see it now?
Yeah.
I don't even know how to figure sand color out here. I'll make the sand orange. This is the sand. Do you see that now? Just like little crabs walking around, you know, all that business. Okay, so Jill's lifeguard post is 18 feet away from the flag. And Joe's lifeguard post is 26.5 feet away from the flag. Jill and Joe's lifeguard posts are in line with the flag on the beach, and the drowning man is perpendicular. They're telling you this so you know it forms a right angle so that you can actually use the Pythagorean theorem. Hannah, Corey, gosh. Who is farther, seriously, who is farther from the man by straight line distance and by how many feet? So we are going to do the Pythagorean theorem to figure out their distances from drowning man. So we'll start with Jill's distance. I'm going to call Jill's distance x and Joe's distance y. So Nick, set up the Pythagorean theorem to be able to find Jill's distance x here if you know that she's 18 feet from the flag and the man is 30 feet from that. What would the Pythagorean theorem be for this one?
18 squared plus 26 squared.
Be careful.
So it's 30y squared.
It's just 30 feet. Sorry, the y and the x are...
X squared equals 26.
It equals this distance here. So leg squared plus leg squared equals hypotenuse squared, okay? So our hypotenuse in this case is x. So just make sure you're like recognizing that you're only looking at this left triangle here, okay?
So, okay.
They're all like, there's multiple triangles going on. I don't know what 18 squared is. What is 18 squared? 324, is that what you got?
Yeah.
Do they make like big whiteboard calculators?
I don't know.
I mean, they've got like the giant compass. I feel like there seems to be a big magnetic one that can just...
I mean, you can like, I could project calculators though on the board, or I could like put one under a document camera.
I just think it would be really funny to have them big above you and you have to like push it forward.
So we round to 2 decimal places if it doesn't tell us. So what does this round to? What is the square root of 1,224? What is that? Anybody? Point 99. That's 34.985, so that would be 34.99, right? I always just round to 2 decimal places. I mean, if you did that, I would not probably mark it wrong in this case because 99 is basically 5, so. Okay, Jack or Joe. I keep calling him Jack. How do you find Joe's distance there? Alana, what would you do? Equals y squared. So did I add those right? So when you take the square root of that, what do you get? Rounded to 2 decimal places. Take the square root of 1,602.25. 40. Point what? Do you have it on your 03. Okay, so who is closer to Drowning Man Dave? Oh, I just called him Dave. Who's closer to Drowning Man? Dave is from the last problem, but we can call him Dave if you want to. So Jill is closer by how many feet? So all you would have to do is do 40.03 minus 34.99, and what do you get?
I mean, Dave was an inconvenience in the last problem. Maybe that's why we're doing the math instead of helping him not drown.
No, Jack and Jill aren't doing them, or Jack and Jill. Jill and Joe aren't doing any math. They are currently running to save this drowning man. We are the ones doing the math.
I don't know. They're still standing on the post.
Currently, yes, I guess you're all right.